Hi, and thanks for joining us today at the Elastic Community Conference. And welcome to our talk on how we approach troubleshooting an Elasticsearch cluster here at the Elasticsearch support team. Let's say we're in a situation where our Elasticsearch cluster is down or performance is highly degraded. Sometimes this happens out of the blue without the users anyhow being aware of any reasons for that. While we're trying to keep our cool, things can easily escalate as well. And at times you have unhappy users, managers, the account team looking after your shoulder and wanting to make sure that an issue is addressed as soon as possible. How can we be ready to deal with this? Knowing what to do and how to work in such issues is the key to keep calm. As an Elastic support engineer ourselves, part of our job is helping our customers navigate these kinds of situations, as well as advising which tools and knowledge sources to turn for help. And today we'll share our approach with you. After this talk, we hope you feel more confident when troubleshooting Elasticsearch, and you will also be knowing better what resources you have at your service, and ideally it will help you to avoid any outages due to common issues in the first place. So what's our approach to troubleshooting? How do we go about our everyday job? We would like to use the analogy of an emergency room here. Although fortunately for everybody involved, there's not a life-threatening situation at hand at all. However, it still makes sense to compare how we work at Elastic Support, comparing to how this works in a medical staff environment and how they deal with emergencies. Imma will now walk you through the approach with the help of a couple of visuals she created for us.
Thanks, Janko. And this is how we see it in 4 steps. We'll zoom into the first step, triaging. In triage, we focus on identifying how life-threatening a situation is. Is the cluster completely down or unresponsive? Are we dealing with degraded performance affecting the customer's business? Those cases will be treated as urgent and will be worked together with the customer 24/7 until stabilized. To do this triage, it's important to ask questions that can help assess how critical it is. Take a step back and get an overall picture of what happened before diving in. We'll ask for the cluster health. Is it red, yellow, green? Similar to fever on a patient or other vital signs, it's the first sign of urgency. Symptoms, is the cluster unresponsive? Is the cluster up but critically impaired? Slow ingest, slow search, nodes leaving and rejoining the cluster, data loss. We'll ask what happened when this started. Sometimes we oversee this, but there can be several changes that led to the situation. From a patch at the operating system level, Elasticsearch configuration changes, increases in requests volume, etc. Knowing this might guide us to the cause, but more importantly, can help us stabilize the patient. If it's something we can quickly revert or roll back, we might get to a better place sooner, and we can investigate the root cause with less pressure. Finally, did anyone already attempt anything to fix this? For example, were the nodes restarted? Any change in cluster settings? Based on the triage, if we determine the situation is not urgent, we'll schedule a regular appointment. For Elastic Support, what that means is that we won't be working 24/7 to fix this. We can take some time to find the root cause during regular office hours. The support engineer that usually works with that customer, like the usual doctor would, will have a full picture and will be better able to help. We use the emergency room to stabilize urgent cases. We need to keep room for incoming new emergencies, though we'll also keep cases here that are not critical at the moment if we think that not fixing this will probably cause an urgent issue. We do not want to send the patient home and having to come back later with an emergency. If the issue is urgent, we'll proceed to the second step, the diagnostics. Similar to what doctors have, X-rays and blood tests, we also have several tools at our disposal. The ones we use the most are included here. The Elasticsearch REST APIs we use a lot, and we have the support diagnostics utility that helps us gather all the relevant calls faster. Janko will get into this later. We will usually gather the node logs, which can help us understand what is happening. And finally, we'll write monitoring data. The whole Elastic stack can be monitored, and this gives us historic data that is very useful. Armed with the necessary information from the diagnostic tools, we will search our GitHub open repos for known issues that can be related. We can also search on Stack Overflow, Elastic Discuss forums to look for similar issues and what other users did to solve them. Internally, we have a knowledge base of our customer cases, so we'll also search there. And of course, we can always Google it. We are not alone troubleshooting. We have an internal support Slack channel and a Zoom always on room where our colleagues are ready to lend a hand. We might need help from our developers, and for that, we can open a thread with them. We use internal GitHub repos for that, and we also use Slack. With this information, We will reach a diagnostic, and we can propose a course of treatment. Treatments will usually be tactical, aimed at stabilizing the situation. For example, we can decide that the cluster at full storage will stabilize adding nodes or deleting data, and we'll just do that. If the treatment does not work, we'll go back to the diagnostics. Maybe we solve one issue, but it was not enough to stabilize, or maybe nothing changed. We'll gather information again and keep analyzing until we succeed. Once the cluster is stable, we can suggest some best practices to prevent future occurrences, similar to when the doctor sends us home with some medicine, dietary recommendations, and the likes. We might also send the patient to a scheduled appointment for a follow-up to help prevent future occurrences. When dealing with urgent issues, we do not usually have time for root cause analysis. We need to clear the emergency room for other incoming emergencies. If the cluster is stable enough, we'll move on to other urgent patients and stop working 24/7 on this case. This is the analogy we'll use in this presentation. Janko will walk us through a concrete example of a common urgent issue, showcasing how we approach each step. And before we get into an example, though, just a quick note on how we chose that example. We thought it might make sense to start with the most common urgent Elasticsearch cases we see in support, and pick one out of those. And for that, we built a Kibana attack cloud that reflects some of the most common issues we see. When we were going through this talk with Janko, a new high-severity case titled Red Cluster just came in, and it made sense to us to focus on a red cluster case. We also wanted to share another example, a cluster that is suddenly showing inches delays, but we are a bit short on time today, and we'll have to leave this for another time. I just wanted to mention finally before we move on that urgent cases are a minority of our work. We do not only help customers with outages. In my case, I think it's maybe 5% of what I do or less. It depends on the week or the month. We get plenty of cases we call consultative support. In those, we help our customers configure, discuss best practices, give advice on architecture, design new features, and so on.
Okay, so let's start digging into a typical support case then. Here we have an example of an urgent severity case. The customer has informed us that the cluster has a red status. It's also not ingesting any data. And the first thing we'll do, as Imma said, we're going through triage. Even if the customer might already have told us some of the symptoms they can see when opening the case, we still assess severity and impact, and we're going to get a bit of a better look to see what else we can find. This will help to get us more context and help with our diagnosis. We see vital signs. The customer noticed that the cluster is being in red and that there is no ingest ongoing. If we're using the get_cluster health API endpoint, we can see this and other interesting metrics here. We can see that active shards percent as number shows that some shards are missing, and unassigned shard is reporting as 1. We will further inquire about the symptoms. Is the cluster totally unresponsive, or do some operations still work? Are there any errors that are shown in the logs? So now we're looking at what happened. The customer has no more information that could help us any further with the things that happened. No changes have been made from their part prior to this issue starting. And what they observed is that the ingestion stopped, and at the same time, more or less, the cluster became red as well. Did they try anything to fix this? No, so far the customer did not try to restart any nodes or change any of the cluster settings in this case that we're looking at. So what to do next? If the customer did not share a support cluster diagnostic with us, then we're going to ask for it, as well as any Elasticsearch logs around the time frame that this issue occurred. If the cluster is still responsive to the REST APIs, then this support diagnostic will give us a lot of information that we can use to analyze the cluster state, its behavior in the past, setup, and all of these kind of things that can lead us to a bit of a more wholesome view of the cluster itself. In this presentation, we're going to use the REST API calls, but also have a look at the URLs provided here because they explain the information that you can see in that diagnostic, which API calls are used, and so on. It's really useful. Then once we have a support diagnostics, or if in case of a screen share, we have access to the cluster to troubleshoot live with the customer, we can also run a few API calls from there. This will help us to figure out more. First and foremost, we want to find out why the cluster is red. The cluster health itself reflects the health of the worst index and the worst chart state. So this means that here we have at least one index with one unassigned chart because the cluster is red. We can execute some of the CAT APIs. CAT stands for compact and aligned text, which are a bit more human readable than the APIs that return JSON output. First, we'll run CAT indices API, and we added some parameters here so help with the readability. As you can see, there's one index red in this case. We have no documents in event log 7 at all. So let's dig into this a bit more. Next, we're going to look at all charts. We're going to sort on the state, descending for the shards, so we can see what their specific state is. And specifically for primary shards, if they're in the initializing or unassigned state, that would cause a red cluster that we could see. And indeed, that's the case here. As we see, event log 7 has one primary shard which is not allocated. If it was a replica, we would see a yellow state, though this being a primary, we have a red state here. We have no data for that index, and therefore it is red. So let's figure out why the shard is not allocated. We can use the allocation explain API to get more information about a specific index and the shard, and we add this here in our payload. Then in the output, we get a little bit more information than just from the health API. The explanation in this case seems related to the fact that the node where the shard should be living has reached its high disk watermark, and we don't have any space left on it to write. So finally, we can look at the cat allocation API to check how much storage is available. Here we have a single node cluster as an example. It's relatively small with 21 gigabytes, and we have less than 1.9 gigs remaining. So why did Elasticsearch then stop all of the ingesting, and why did the cluster health become red? We can understand that if the index event 7 does not yet exist, that index is not available, and we cannot write into it at all. But we also see that the cluster cannot ingest into any other indices either. So if we're looking at the cluster settings, we'll notice the default disk allocation values have been set. If we go about 90% of our disk usage, the cluster will become read-only to protect itself. Not only will it not assign new shards, it will also block writing on existing indices, and therefore we have the explanation why all ingesting has stopped here. Any attempt to write to an existing index now will fail, and we can only execute read and delete requests upon these existing indices. Therefore, we can notice that the search still worked, but not the ingestion. Even if we tried writing into an index that's not in a red state, the cluster setting would block this. Now that we know what happened, it's time to fix it. The quickest way is to increase the available disk size. We can add nodes, or alternatively delete all the data, reduce data retention. If needed, we can also restore indices later that we have snapshots for. And if possible, we can also always re-ingest data from the source if needed and possible in our use case. Tactically, we could also do a change to the watermarks themselves. Although those are not really recommended actions, it might be a temporary hotfix that you could use. These watermarks, they are put either in percentages or in absolute values. And this, especially on larger disk sizes, would enable us with absolute values to have a bit of a better control of our disk space used. But we need to be careful not to set it too low or too high. This we can set while we figure out what happens. Once we recover enough storage, we can check with the allocation API that we saw earlier if we might remove the index write blocks on the affected indices. Here we can see we set the write block, we can write again. And we also present a quick bonus trick, which is a bit more advanced in case there is any cluster that was read due to shards that were corrupted, or if only we had a stale shard, both not really ideal situations and not the case in this example. But if that should happen, we can manually force the cluster to allocate use using allocate stale primary or allocate empty primary flags. We're accepting data loss here, but it can help us to partially recover data in some cases where there is no snapshots available, and some of the shards themselves are not recoverable. Finally, we also have some recommendations and best practices. Make sure you have alerts in place for node storage used. We recommend to keep the cluster usage around 75% disk usage so that there's room to growth until the 85% low disk watermark. If you're using tools like index lifecycle management, this can help to make sure that all the data is deleted. Alternatively, use data tiers, where in the cold tier, we can also remove replicas on the nodes while using a snapshot as a replica, for example. Also remember a general best practice to use snapshot lifecycle management to make sure you have your data backed up in case you need to delete data temporarily, to make room, or to recover from any data corruption or loss that you might have. And here we can see finally a summary of what we discussed for future reference. The symptoms, what we use to reach a diagnostic of the situation, how we can fix it, and what we should recommend to prevent this in the future.
Thanks, Janko. Very interesting walk through the red cluster example. We were able to dig deeper into one of our favorite tools, the REST APIs and the support diagnostics. Even if we do not have more time in this talk to see other examples in detail, we do wanted to mention other tools we use in our day-to-day at Elastic support. and include some of the most common recommendations and best practices we share with customers, hoping this will help you get a more complete picture of how we work. The Elastic Stack has its own monitoring tool that comes in very handy when troubleshooting, amongst other things. With the APIs, we get current values, a snapshot of the moment, but we are missing historic data. What happened during a past incident, what did our cluster look like, or what changed when the current incident started. In this slide, we can see that thanks to monitoring, we can locate an ingest spike. If an issue started at the same time, we have something to start investigating. An important recommendation we often share with customers is to use a dedicated monitoring cluster in production and metric bit for data collection. We sometimes see cluster performance impacted when self-monitoring, so we do not recommend it for production. Use a dedicated monitoring cluster, even if it's one node cluster. Monitoring will show us how we are doing in terms of JVM Heap, for example. One of the things we'll first look at. We can see the memory contents for each node, and we have useful tooltips on the graphs that helps us understand the different memory usages we have at Lucene or Elasticsearch level. If we spot any changes here, it can help us point into the right direction for diagnostics. Monitoring data can also give us insights on index and search queues and rejections. Is the cluster too busy or even rejecting requests? This is also something we can look at in monitoring. Rejections in the APIs using cat thread pool show a cumulative value that resets when we restart a node. So value is not always a significant of a current issue. With monitoring, we can see the rejections and queues over time, which I find it very useful. We'll now go into a quick example to showcase how we use monitoring. In this slide, we spotted high CPU on the master elected node. We have a 3-node cluster, which is also a data node, instance 9. We can see instances 8 and 10 show a CPU usage below 10%, with no CPU throttling, while instance 9 is almost at 85% and even throttling. This example comes from the first slide I showed in the section, so we know that the CPU spike started with the spike on ingest. And this is what would guide our investigation into ingest here. Side note here, before going to the next slide, keep in mind that monitoring can also help us with alerts like the one we see in the slide, alerting of high CPU usage on instance 9. With those, we can proactively investigate issues, and I do recommend you use alerts. Selecting the indices tab, we see that some of the indices are ingesting at a higher rate than others. We start suspecting index hotspotting here. That is, maybe instance 9 is holding more of the primary shards that belong to those indices and needs more CPU for writing, while the other instances are somewhat more idle because they are not holding any of those primary shards or are holding less of those. We could confirm this using the monitoring UI, which will also show us where each shard is located. But we can also combine it and use the cat API to confirm our suspicions, which are that indices are defined with just one primary shard, and most primary shards landed on instance 9 for those indices. We could also use the hot threads API to check if most CPU is used on writing operations, for example. What we would see in real life is usually high CPU shifting from one instance to another in those cases. If an index is rolled over, for example, and a new index is created, the hotspot shard can be allocated to a different node, and CPU usage might shift to another node in the cluster. It's a good idea to look for index hotspotting in those cases where we have uneven resource usage between nodes. What we can do to make use of all the node CPUs, instance 8 and 10, once we confirm the issue, is working with 3 primary shards for the indices with the hottest ingest instead of 1. One primary shard is usually okay, but if we have just one or very few hot indices in our cluster, we might need to spread that load on the cluster nodes more evenly. In this way, we would be using the CPU we have available also on instances 8 and 10. High CPU can also be caused by slow disks, and in those cases, we'll see CPU waiting on disk I/O, and we must check other scenarios also. More than one Elasticsearch instance on the same host without proper resource isolation can cause the instances to compete for resources. If working on virtualized environments like VMware, we recommend to avoid CPU overallocation for better performance. So there can be various root causes, and we'll use the tools we have available to figure out with the customer which one it is. We won't go into search issues here, but similar investigations can be done for search. The point we're trying to make here is that in support, we combine the different tools to try to reach a diagnostic, and once confirmed, we decide what treatment we can apply. Another very useful tool is analyzing logs with Elastic Stack. We can ingest logs into our monitoring cluster with FileBit, Once we have the logs available, we combine it with the information we get from the REST APIs and monitoring data to troubleshoot. As you can see in the slide, we can take advantage of Kibana Discover. In Kibana, it's easier to filter for log level, the instance, remove noisy logs not related to the issue at hand, and so on. We won't get into this today, though we wanted to mention log analysis too. From experience, we recommend you be proactive. Know your cluster logs, investigate logs that should not be there, especially warning and errors, but sometimes also info or debug logs. Look for logs complaining about failing bulk hinges, circuit breakers, mapping problems, template issues. Do not ignore logs, even if the cluster is in good health. They might cause problems in the future. I also find it particularly useful to keep logs clean. In this way, once you have an incident, you won't be distracted with logs that were already there and might not be related to the problem at hand. We're getting to the end of this talk, and we did not want to leave you without sharing some of our usual recommendations to customers. We know we have plenty of documentation, blogs, webinars, awesome trainings, lots of resources, and it's sometimes hard to figure out what are the most relevant. From a support perspective, what Janko and myself have done is collected some of the documents we most often use when helping customers, and we decided we'd share those here. It's not a comprehensive list, it's a curated selection of what we find ourselves often referring to when talking to customers. As we're a bit short here, we'd love to have some time for the Q&A. We'll just leave you this link so you can have a look later on your own. And this is the second slide with a few more links. I'm back to you, Janko, for wrapping up.
Thanks, Imma. Just to conclude this talk, which we hope was useful and interesting for you, simply remember the emergency room analogy. Triage your incidents. Look how critical it is. Do we need urgent care? Have your tools ready, monitoring and alerts, log analysis using Kibana, REST APIs. Also, don't forget to search. We did not discuss it much in this talk, but as support engineers, we will need to be experts on search anyways. Find existing bugs and if and where they might have been fixed already, similar issues that occur to others, users or customers that can inspire us or maybe even directly bring us to the solution. Once fixed, learn from the incident and apply best practices. Even better if you can put them in place first, so to avoid any potential incidents in the first time. And with that, we would like to thank you for your attention, and we're happy to take any remaining any questions in the remaining time that might be there.
All right, so let's have a shared view over here, like this one. So I don't think there were a ton of questions in the chat, with the exception of the slides that will be shared, but they will also be part of the video. Maybe just to ask one of my standard troll questions, like, what is the number one thing that you expect for a support case to be there that basically helps you the most to dig into an issue? Is it the diagnostics? Is it a special part of the diagnostics that you would say is absolutely important and you can't live without? Is it the operating system?
Well, I would say the operating system and things like that is all part of the diagnostic. So if you can get a complete diagnostic and ideally complete log files, we can then go and check for things. What doesn't help us much is I have a problem, this doesn't work, and then nothing more. So we need something to go on, and we need some details to be able to check what happens.
It usually depends on the issue. If it's something that's happening now, you can do with diagnostics and logs. But if it's something it's been happening, some monitoring data can help you see what had been going on. But usually we start asking for diagnostics, and then we move to logs, and then at least myself, and then I move to monitoring data if I need that. So diagnostics is usually the first one for me too.
All right, do you have any different, so one last question, as I didn't see anything else, do you have any different approach to different kind of problems, like performance problems when searching or ingesting? Like, is there like very different things of how you tackle a problem, or is it all like take a broad overview first and then dive into the details, or do you have kind of a schema that you follow for these kind of things as well?
For me, that depends. If for ingest, we usually try to isolate if it's Elasticsearch, if it's a component in front of Elasticsearch. So you try to work on each component separately. Make sure if you have Kafka, Logstash, whatever you have, try to isolate each one. Is it Elasticsearch? Is it Logstash? Is it bits? What's causing the issue? For search, I think we usually start with diagnostics, but we have, when we know it's as low searches, we have profiling APIs to see if the search is a problem. So I guess it's different between ingest and search. But mainly diagnostics is the way to go, usually, to start at least.
Yeah, I like that. The big bad overview about everything, and then you slowly put the pieces together. All right, so we've reached our time limit. We'll have a super short break and then continue with the next one. That said, Imma, Janko, thanks a ton for presenting. I think it's always super useful for me to dive into how other parts of the company working, especially with customers. I think there's a one last Q&A, so if you want to take a look in the chat, you may want to take that one. And that's it. Thanks a ton, and we'll see you in a second.